This is part of a series of demonstration videos to review how openstack-helm works. Openstack-helm is an open source project that aims to provide a fully self-contained Helm-based OpenStack deployment on top of Kubernetes. In this video, I'm going to review the infrastructure components and OpenStack services deployed with openstack-helm. We will also perform a Nova boot so we can demonstrate a simple tenant compute host that's functioning with an openvswitch flat networking model. So before we start looking at the containers on the right-hand side, I just want to give you guys an overview of what's going on in this physical environment. So we have 5 physical hosts in this environment, and we actually have a picture that makes this a little bit more clear. The easiest thing to keep track of is really the digit at the end of each host. So 04 is the Kubernetes master. 5, 6, and 7 are all control plane hosts. And 08 is a tenant compute host. We control the role of each of these hosts with Kubernetes labels. And in addition, on each of the control plane hosts, in addition to housing the core OpenStack services themselves, they are also running Ceph containers, and that is deployed using our Ceph chart in openstack-helm. Each of the hosts have 3 physical network connections. The first is a provisioning network to MAS. The second is an administrative network, which I'm SSH'd into. And the third is the OpenStack flat network plugged into openvswitch that we're using for the demo. So we're going to go ahead and log into the Horizon dashboard, which was deployed as part of deploying openstack-helm. We enabled the node port option on it so that we can actually access it through any of those bare metal hosts. I just so happen to be accessing it through the Kubernetes master at the moment on its node port, which is 30,000. We're going to log in with the default credentials that the openstack-helm charts provide. One thing I just wanted to review really quickly is the various OpenStack services that are installed using openstack-helm, at least in terms of the 0.1.0 release. So as far as infrastructure components, we install Ceph as a foundational layer on all of the control plane hosts. That helps provide a backend for Kubernetes persistent volume claims, of which the only chart that we have that actually leverages that is the MariaDB chart, and it leverages that for persistent storage for the Galera database cluster that's actually powering the various OpenStack services. In addition, we deploy Memcache and Rabbit, obviously, and then for the core OpenStack services, again, for the 0.1.0 release, we deploy Keystone, Nova, Neutron, Heat, Cinder, and Glance. Obviously, openvswitch is another foundational infrastructure piece, and that also gets deployed as 3 separate containers. Essentially, the OVS vSwitchD process, the OVS database, and the OVS agent. Each of the control plane hosts and the tenant compute hosts all run these openvswitch containers because the control plane hosts are housing the Neutron L3 services, the Neutron DHCP services, and the Neutron metadata services, and obviously the tenant compute hosts are housing virtual machines that Nova is spawning that similarly need to access the network. So what I want to do next is I want to create a tenant VM just to show that that is functioning and that we can actually reach it from the Kubernetes master host and just verify that it actually lands on our tenant compute host DB08. So we're going to launch an instance really quickly. We're going to call it demo123. We are not going to boot from a volume. We're going to leverage the Ubuntu Precise image, which we've injected into OpenStack once openstack-helm has stood up the cluster. We're going to use a flavor that we created, again, after openstack-helm created the OpenStack services. We're going to use a flat shared network, again, that we created after openstack-helm stood up all the OpenStack services. We're going to use a default security group that we augmented to support SSH and ICMP. And we're going to use a test key pair that we've already loaded. I'm just going to go ahead and launch that. So our instance is spawning right now, presumably on DB08. It's now active and likely in the process of booting. But let's just validate that we can see it inside a Nova list. And again, I'm communicating with OpenStack from the Kubernetes master. Let's just quickly take a look at our authentication credentials. We are talking to the Keystone API Kubernetes service, which is distributing all Keystone API requests among all of our Keystone API containers. Those are all created inside the OpenStack namespace, and we are using the default credentials that openstack-helm leverages, which are fairly simplistic. So we do see that our host is active and running, and I just want to take a closer look at this host, and we should see that it is running on DB08. And at this point, we should also be able to ping this host. And again, we are pinging this host from a completely separate bare metal host, the Kubernetes master. And on top of that, we should be able to SSH to this host. So quickly, I also want to briefly just show you some of the other foundational infrastructure elements. So again, we mentioned that Ceph is deployed. There is a Ceph chart inside Openstack-helm that deploys essentially three components. The first is 3 separate Ceph monitors as a stateful set, and then also Ceph OSDs, again, as containers across the control plane hosts. So because we have 3 control plane hosts, we see 3 Ceph OSD containers. Obviously, if we had 4 control plane hosts, that would expand. The only chart today that we have that's actually leveraging persistent volume claims is the MariaDB service. Again, this is also deployed as a stateful set. This requests persistent volume claims from Kubernetes, and as part of the Ceph chart instantiation and orchestration, that sets up a Kubernetes storage class that allows these MariaDB charts to go ahead and request a generic Kubernetes persistent volume, and that is affected through creating volumes inside Ceph automatically. In addition, the other infrastructure components that are deployed in order to enable OpenStack is obviously a Memcache container, and then obviously a Rabbit container to support RabbitMQ service. As part of a subsequent release, we are working through making both the Memcache service and the RabbitMQ service scalable and more resilient. At the moment, the current release today, we only deploy one container for each of these two services. The OpenStack services themselves are already resilient. We deploy multiple copies of each of the API services for the purposes of resiliency. The other item that I wanted to demonstrate is validating the fact that our tenant virtual machine that we have created, while it's running on DB08, one of our philosophies with openstack-helm is that everything runs as a container. So that means that infrastructure services like Ceph are running as a container. Other infrastructure services like our Galera cluster is also running inside containers. And then finally, all of the OpenStack services like the Nova Compute agent, libvirt, and then of course all of the openvswitch processes themselves are also running as containers on the tenant compute host. And then again, for some of the openvswitch components, those are running in containers on the control plane as well. And a good demonstration of this, I think, is if we actually connect to the physical host that's housing that machine in a non-containerized environment, we would typically expect that we could list the virtual machines that are running on that host, but we find that this bare metal host actually has none of the virtualization software installed on it. Instead, libvirt is actually running inside of a container. The benefit of this philosophy of having everything run as a container means that at the end of the day, even these infrastructure elements such as libvirt and Ceph can go through the same release cycle and software publishing cycle that OpenStack itself goes through. So we don't have a separate release and upgrade strategy for infrastructure components like libvirt as opposed to releasing new updates for OpenStack itself. And so just to demonstrate that we can actually access libvirt inside the libvirt container, I'm going to use a utility called weavescope, which will have a separate demo video about that will go into some of the interesting things that you can do with this utility that provides some nice visualization into the Kubernetes environment. And so we're just going to drill into the DB08 host and look at the various containers that are running on it. One of them is Nova libvirt itself. And so we're going to hop inside that container and do the same thing that we would expect to be able to do on that bare metal host. And at the end of the day, we should be able to line this up with the instance that we just deployed. So we can see that instance 13 is running on DB08, only that the libvirt process itself and all the software that compose the libvirt process are actually wrapped inside of a container, making the potential for upgrading and releasing that software go through the same path as all of the other OpenStack components. And that is the end of this video. Thank you.